Welcome to The Explainer. So let's talk about one of the most fundamental ideas in all of AI. How does a machine, or an agent, figure out the absolute best way to get from point A to point B? This is a huge deal. It's the magic behind your GPS. It's what makes game AI so smart. It's everywhere.
Okay, let's make this real. Imagine this. You're completely lost in a brand new city. Let's say Arad, Romania, and you have to get to Bucharest to catch a flight. You've got a map, you can see all the roads, all the distances. So what's your plan? What's the smartest way to find your destination? You're not just going to start driving around randomly, right? You need a strategy.
Well, that exact puzzle you were just thinking about, that's what people in AI call a search problem. It's this constant challenge that AI faces. It's all about figuring out a sequence of moves, a path, that takes you from where you are now to where you want to be. It's really the core of how any smart system makes a plan.
So if we want a computer to solve this, we have to be super precise. We have to spell it out. We basically break it down into three key parts. First, the initial state. That's easy. It's just I'm in Arad. Then you have your actions. These are all the roads you can take, right? Go to Sibiu, go to Timișoara, those are your options. And finally, you have the goal test, which is basically the computer constantly asking itself, am I in Bucharest? Nope. Am I in Bucharest yet? Nope. Pretty simple, right?
Okay, so we've got our problem all set up. Now, what's the most basic way to solve it? You could literally just try everything, and that's a real strategy. It's the brute force method, or what AI folks call an uninformed search.
So one way to do this is something called breadth-first search. Just picture it. You start in Arad, and you drive to every single city connected to it. Okay, check. Now, from all of those new cities, you drive to their neighbors. You see what's happening? You're exploring outwards in these massive, ever-widening circles. You have absolutely no clue if you're getting closer to Bucharest or further away. You are, quite literally, searching blind.
Now, this whole blind approach, it's got its pros and cons. The good news is it's complete. That's a fancy way of saying if there is a path to Bucharest, this method will 100% find it. And it'll find the one with the fewest stops, which is cool. But the bad news? Oh, it's bad. It is unbelievably inefficient. Just think of all the wasted time exploring paths that are obviously going in the wrong direction.
So, how inefficient are we talking? Let's put a number on it. For a problem that's not even that crazy, say one where the answer is about 16 steps away, a brute force search like this one could take, get this, around 350 years to find the solution. Yeah, 350 years. So obviously for anything in the real world, we need a much smarter way.
And that leads us to the big aha moment, the game changer. What if our search wasn't blind? What if we could give our little AI agent a hint, a little piece of extra information to nudge it in the right direction? Well, that is the core idea behind what we call informed search.
So let's just lay it out. On one hand, you've got uninformed search. It's just blindly checking every single option. It's methodical, but it's not smart. On the other hand, you have informed search. This is where the magic happens. It uses some extra problem-specific knowledge, basically a good guess, to help it decide which paths are actually worth exploring.
So where does this good guess come from? It comes from something with a kind of fancy name, a heuristic function. But don't let the name scare you. A heuristic is really just a rule of thumb, an educated guess. For our road trip, a brilliant heuristic is simply the straight line distance to Bucharest, as the crow flies. It's not the actual road distance, of course, but it's a super useful, quick and dirty estimate of how close we are. In the biz, they call this h of n.
All right, so now that we have this powerful idea of a heuristic, researchers have built some really smart search strategies on top of it. We're going to look at two of the big ones, a strategy called greedy best first search and the absolute legend of the field, A-star search.
Okay, first up, greedy best first search. And honestly, the name tells you everything you need to know. It's greedy. At every single intersection, it greedily picks the road that looks like it's closest to the goal based on our as the crow flies heuristic. It's got total tunnel vision. It doesn't care how long it took to get here. It only cares about one thing, getting closer to the goal right now.
So let's follow the greedy path. We're in Arad. The heuristic says Sibiu is the closest city to our goal. So boom, we go to Sibiu. Now we're in Sibiu. Heuristic looks like the best option from here, so we go there. And from Heuristic, hey, we made it to Bucharest. The algorithm found a path, no doubt, but it's not the best path. This route that seems so direct is actually 32 kilometers longer than the optimal one.
So why did it mess up? Why isn't it optimal? Well, because our as the crow flies guess doesn't know anything about the actual roads. A path might look like a straight shot, but it could be a slow, winding mountain road. The greedy search is so focused on that future estimate, it completely ignores how far it's already driven. And to find the truly best path, you gotta balance both.
And that brings us to the hero of our story, the famous A-star search algorithm. A-star is basically the superstar of pathfinding, and it's because it's so much smarter. Instead of just being greedy and looking at the guess for what's left, it brilliantly balances two key things.
Its secret sauce is this beautiful little formula. A-star figures out the total cost of a path, which it calls f of n, by adding two numbers together. First, you've got g of n. That's the real actual cost to get to where we are right now, the kilometers we have already driven. No guesswork there. Then it adds h of n, which is our old friend, the as the crow flies guess for the rest of the trip. So it combines what it knows for a fact with its best guess, and that makes its decisions way more intelligent.
So let's put them side by side. You've got greedy search, which is totally short-sighted. It only cares about h of n, the guess. But A-star is the wise one. It looks at the big picture by combining g of n, the path so far, with h of n, the guess. That's why A-star finds the best path most of the time. Now, see that little asterisk? That's an important detail. A-star is only guaranteed to be optimal if its heuristic is admissible. All that means is that the heuristic has to be an optimist. It can never overestimate the actual distance. And our as the crow flies guess is perfect for this.
Okay, so I know we've been talking a lot about a road trip in Romania, and it might seem a little abstract, but trust me, the ideas behind informed search, and especially A-star, are secretly running the world all around you. Let's talk about why this actually matters.
Think about it. Every single time you pull up a map app and ask for the fastest route, yep, that's an A-star style algorithm at work, balancing distance and live traffic data. That robot zipping around an Amazon warehouse, it's using A-star to find the best path around all the shelves. But it goes way beyond that. It's used for designing the microscopic circuits on a computer chip and even for mind-bending problems like figuring out how proteins fold themselves into just the right shape.
So in the end, what's the difference between a dumb search that takes 350 years and an intelligent one that's over in a flash? It all comes down to one thing: having a good heuristic. It's the art of finding that perfect rule of thumb that lets you slice right through a massive, overwhelming number of choices. And that kind of leaves us with a final question for you. What's the biggest, most complex problem you're trying to solve? And what good guess, what smart heuristic could help you find the absolute best path forward? Thanks for joining us on The Explainer.